Thank you for inviting me, and thank you. Yes, I do think you are the most appropriate group to give this talk to. So yeah, I'm Charles Paxton from the University of St Andrews. I do this stuff as a hobby. It's not mainstream research, but people seem most interested in this. So I'm going to. There's not very much technical statistics in this talk. It's more kind of philosophy of statistics, really. And I want to talk about the potentialities and some constraints associated with using anecdotes data, and tell you a little bit about the Loch Ness Monster, things you won't have heard before about the Loch Ness Monster. Well, am I talking about the Loch Ness Monster, or am I talking about something else? Well, that'll become clear in a moment or two. But the Loch Ness Monster, well, you may not agree they exist, but it certainly exists as a cultural phenomena. It encourages people to visit the Highlands, generates people producing objects we will buy, like this postcard, and we'll return to this postcard a bit later on. And I think it's really interesting because I mentioned critical thinking and so forth, and I think thinking about the Loch Ness Monster and problems related to the Loch Ness Monster is a good way to think about the limits of statistics, the limits of science, what science can and cannot tell. And the titles I've given it here, which is slightly different to the one I advertised, is actually based because there was this book that was published in 1934 by Rupert Gould, which is the first book on the Loch Ness Monster. Maybe there was a booklet before that. And basically, Rupert Gould, when the Loch Ness Monster blew up in 1933, he then motored around Loch Ness on a motorbike and interviewed various people, and then published a book about it in 1934. And he had various ideas. And the Loch Ness Monster in 1933, well, it really started in 1933. You've heard stories about it earlier, but really it started in 1933. It blew up in 1934 to the extent that the Inverness Tourism Board decided it didn't need a budget in 1934. There were so many people coming to visit the environs of Loch Ness. And of course, it does contribute to the tourism industry of the Highlands even to this day. Okay. And my interest for a number of years now has been publishing, has been looking in, I've always had a sort of interest in sea monsters and things like this ever since I was a child, but actually about 2.5 decades ago, I really thought that actually the science could say a lot more about this topic than actually currently people do. And it could be quite interesting. And one of the first things I published, which I'll tell you about in a moment or two, was a paper looking at discovery rates for new animals. And since that time, I've done other ones using statistics, using anecdotes of data, and I'll give a justification for that in a moment or two. And just looking at features of these reports and what they can tell us and what they can't tell us and what the limits of statistics actually is. So almost everything I'm talking about today is going to be published, apart from the very last bit, which is new stuff. Now, the first thing I really want to make clear is that, and I know some zoologists are a bit surprised about this, we are still discovering large, marine animals. Freshwater, not so much, but there have been some described. And here's a list of some of the bigger species that we've discovered in the last few years. Now, some of those are kind of like Balanoptera amiri, have been distinguished on molecular genetic grounds. So you could say that's not really a new discovery. But others of them, like Borradius minimus, 2019, new species of beaked whale, that was kind of a new discovery. It was known to Japanese fishermen, it wasn't known to the scientific community, and it was realized it was actually a distinct form of Borradius, which is a species of elongate whale from the North Pacific. Various other, these are all cetaceans, bar Mola tecta, which is a type of sunfish, and Bathyrraja haspeafricana, which is a giant ray found off the coast of Africa in the deep benthos. So there are unknown animals out there. Whether they're seen by people prior to discovery, that's a different question. A few years ago, I decided I'd do a bit of kind of historical statistics and look at the rate of discovery for these sorts of species. And so I looked at, so this is a plot of a year on the x-axis, and on the y-axis is the cumulative number of species described since 1758, the 10th edition of the Systema Naturae by Linnaeus, which is normally regarded as being a start point of taxonomy. And it's really the black line that you're interested in there. And the point is that that line hasn't flattened off. Now, it's quite difficult to fit models to this data because it's a violation of independence between points. I'm still trying to work out, I had a master's student working on what the appropriate confidence interval should be on this. But the bottom line is that has not reached its asymptote. So there are unknown animals out there. And this is something I tell people. People seem strangely, I interact with the skeptical community quite a lot. I've written articles for them. And some of them seem to think that we've discovered everything. But that just simply is not true. And so the basic premise of what some people call cryptozoology, the hunt for unknown animals, is in a sense, it's still okay. There are unknown animals out there. And I'm talking about the marine environment, terrestrial things. Maybe I haven't really done any work on terrestrial things. And we can break that that graph down. Again, it's the black line you're interested in. The red and green lines are fits. And we can break it down by area, sort of North Atlantic or Arctic. And you see the Arctic, we've probably discovered everything maybe. North Atlantic, maybe there's an opportunity for us to discover some more things. We can break it down by taxa, number of mammals, number of reptiles. There's a possibility to discover new species of mammal, probably less so for reptiles. Based on our existing knowledge, based on the way we currently search for things, and of course we can search for things in different ways as time progresses, so that perhaps other variables have to be added to this sort of model. I'm not going to talk about that too much, but that's just the kind of general sort of statistical problem of potential interest, fitting the appropriate model. And so my point is, though, here's a topic which you might think, there's no kind of statistical kind of relevance to this, but actually, in fact, we can use statistics to kind of discover these things. And that was my first kind of exploration of these sorts of problems, just looking at the discovery curves. And then I started thinking about people's actual reports. Now I know, I'm a statistician, I know that these reports are anecdotes, and I know that anecdotes are not really what we regard as being data for a number of reasons, but above all bias. Of course, it can be untruthful, like regular data can be untruthful, but I guess bias is the real issue. But actually, I've come to the idea that perhaps statisticians could consider anecdotes a bit more than we actually do. And it's worthwhile thinking about anecdotes and thinking about how anecdotes can actually be used by scientists and statisticians, because I think they can be used, but you've just got to be really, really, really careful in the way that you use them. So anecdotes then are part of science. There are non-statistical ways in which anecdotes can be used. They are often initiators of hypotheses. Somebody makes a casual observation. They think, oh, maybe I should investigate that further. That's an important part of science. They can be anomalistic counterexamples against existing paradigms, which make people think, okay, well, it's possible this does happen. They could be the sole source of information about low-frequency natural phenomena. To give you an example of that would be rogue waves. So rogue waves are where these aren't tsunamis, but this is where you get, maybe because of amplification or storm surge effects in the open ocean, really big waves. And the first paper on these really was in the late 1960s, where somebody said, look, we've got these anecdotal reports that this thing's actually happening. And then in the 1970s, they were actually formally recorded on oil rigs in the North Sea and various other places. And now we realise that rogue waves are actually a phenomenon, but they were initially only reported as anecdotes. Now, A, B, and C, I'm sure, in fact, you're all happy with. D, you're probably going, this is where this guy's going to go, really. And so all about is data. We use eyewitness testimony. Well, I'd say, well, here are some comments. The plural of anecdote is not data. You've probably all heard that aphorism. Actually, the original aphorism was by political scientists, late 1960s, and that was the plural of data. The plural of anecdote is data, but anyway, that's by the way. Here's a quote by a sociologist. Anecdotes do not make a science. 10 anecdotes are no better than 1. 100 anecdotes are no better than 10. And I'm quite sure, and in many ways this is true, but can we use eyewitness testimony? Well, I want to quote you a great potential scientist, and that is, of course, Bob the Builder. And what does Bob the Builder say? Yes, we can. Right, there we go. So, can we? The problem with anecdotes is bias. But one issue about whether or not a sample is biased is it depends upon the statistical population that the inference is being made on. So depending on what you specify the statistical population to be, your sample may or may not be biased. So if I collect Loch Ness Monster reports and I want to make inferences about Loch Ness Monsters, my sample may well be biased. But if I want to make inferences about the population of collated reported Loch Ness Monster reports, then sample may still be biased, but it may not be biased for making inferences about that population. And so I would argue that we can look at reports of the Loch Ness Monster, bring them together, reach conclusions about it, as long as we understand what we're looking at are not reports of Loch Ness Monsters. It's not a statistical database about Loch Ness Monsters, but it's a statistical database that is about the reported phenomena. And that reported phenomena has gone through lots of different processes. So there's the initial experience. Somebody sees something, assuming they're not lying. Could be lying. And then they transmit that to memory. And then that message is transmitted to somebody else, typically. It's then recorded, maybe by the same person, but maybe by somebody else. It's then made accessible to somebody else. It's then perhaps collated, and then ultimately somebody like me codes up those results and interprets them. And at every stage of that process, there's potential biases. And so what we see, if we see anything in the sample of Loch Ness Monster reports, we've got to take into account that it's been through this process. So we're not really knowing just about sightings. We could be knowing about other things going on in this process as well. And that's really the main core about it. That's it. That's the message of this talk. And so now I'm just going to give you examples of that and examples of how we can interpret the data and what it tells us about the Loch Ness Monster and some other things as reported phenomena. So the statistical population I'm going to talk about then, I'm going to make inference about, is reported and recorded Nessie reports. And I'm going to make the assumption that the collection is an unbiased sample of the above. The collection I've been collecting things from lots of different sources. I record where the sources come from, and that may have an influence on what the actual reports are. And it's almost certainly a biased sample of Nessie encounters, because presumably the Nessie reports that get kept are the more flamboyant ones. I mean, there are some pretty dull Nessie reports, basically ones like, I saw Nessie, that's it. But presumably, we're seeing the cream of the crop. We're not seeing the more trivial examples of the Nessie reporting phenomena. Oh, by the way, if anybody has any questions, jump in right as we go through. It's probably easier. So what's the data? I've got 2,063 reports from 1,452 distinct encounters. You can have multiple reports from a distinct encounter. They could be from the same witness, which just gives two different reports. It could be from different witnesses of the same report. They're nominally independent. Well, they're nominally independent by encounter. They're certainly not independent from the point of view of witnesses, because, like I say, the same witnesses of the same event, or different witnesses at the same event, or the same witness reporting several times. And depending on what analysis I do, I often just take the first-hand data and take one first-hand report for each encounter to ensure independence. But even then, there may be a violation of independence going on, because it could be that if last week somebody saw a Loch Ness Monster with certain characteristics, then the Loch Ness Monster that's reported this week reflects the characteristics of the Loch Ness Monster the previous week. There are some sightings of Loch Ness Monster dated by the witnesses to before the 1930s, but they didn't report them really until the 1930s. So I tend to do my statistics on the year of report rather than the year when the event happened. Reports prior to 1930, there's one set of reports in 1930. Prior to 1930, yeah, they're a bit kind of equivocal. Most sightings occur prior to 1957, and I'll show you a histogram of the results. One witness per encounter, one account per witness. Witnesses can see the Loch Ness Monster on different occasions. Well, that may say something interesting about the witness, of course, because seeing the Loch Ness Monster without doubt is a very rare thing to do. So if a witness sees the Loch Ness Monster in multiple occasions in different places, you may want to draw an inference about that. And there's questions about independence. So let's have a look at the data. So here's a histogram then of Loch Ness Monster reports by frequency. Actually, this one goes on beyond 2008. And the shaded ones are second-hand reports. So a lot of reports were reported second-hand. By first-hand, I tend to mean as a direct quote the witness. So, you know, the newspaper put it in quotes, even though it could still be dodgy. But in some sense, these are the direct words of the witness, or it's a transcription of the witness's account, or they filled in there was an organisation that was working on Loch Ness in the 1960s that actually got people to fill in report cards where they described the Loch Ness Monster. If you could remember that, that's quite important. So if we classify them by year of encounter, you see basically we've got this big peak, 1933, 1934. Each stick represents a 2-year period. And you can see that, yeah, by year of encounter, lots of people said that they were seeing things before 1930, but in fact, they actually reported them in the 1930s. And you can see that in the 1930s, that was a heyday for the Loch Ness Monster. 1940s, people seemed to have lost interest, something else was on their minds. And then that sort of lack of interest continued until the 1960s, yes, when the Loch Ness Monster, well, Loch Ness Investigation Bureau changed its name. Loch Ness Phenomena Investigation Bureau was an organisation was working on the loch, and that sort of came to an end in the early 70s, and there's been a sort of decline ever since then. So that's the kind of chronological pattern of encounters. Let's do some basic exploratory data analysis. Let's look at the frequency by month. Well, as we can see, it peaks in the summer months. Now, there's several interpretations of this graph. Is it because the activity of Loch Ness Monsters becomes more active in the summer months? Or is it because there's some other process happening in the reporting process that influences these number of reports? If you look at times of day, you can see that there's a peak really in mid-morning, there's a peak in mid-afternoon, but it drops off at human lunchtime. Again, you know, is that a function of the biology of Loch Ness Monsters, or is that a function of something else that's going on the loch? If we look at the Beaufort sea state, so this is what I call interpreted Beaufort sea state. So if the witness said something of like the loch was as calm as a mirror, then I say, well, that's Beaufort sea state 0, etc., etc. So you can normally, if they give a weather report, you can normally interpret it in Beaufort sea state terms. Overwhelmingly, reports of Loch Ness Monster occur at low Beaufort sea states. I'm just trying to remember. The mean Beaufort sea state in meteorological terms, I think, is around about between 1 and 2 on Loch Ness. So it does seem that reports are disproportionately in flat, calm weather. And there may be, well, there's several issues there. One, there could be a detectability issue. Those of you who are familiar with the work in St Andrews know that we worry a lot about detectability. So it could be a detectability issue. We know from marine mammal surveys, if it's nice and flat, you can see further. You see things more readily than if it's not nice and flat. But there could be something else going on to do with flatness in Loch Ness and Loch Ness Monsters that isn't to do with detectability. Duration of report. Well, self-reported duration of report, which is slightly different to actual duration of report. Okay, how long do you think the average Loch Ness Monster report sighting is? As self-reported by witnesses?
2 minutes.
10 seconds.
10 seconds?
2 minutes.
2 minutes?
1 minute.
1 minute?
30 seconds.
Sorry?
30 seconds.
30 seconds?
5 seconds.
5 seconds?
2 seconds.
Oh.
2 seconds?
30 seconds.
30 seconds.
5 seconds.
5 seconds. Right. 4.5 minutes.
Ah, you see, I wasn't far off.
But actually, I think that is the most crackling statistic about the loch. Now, that's reported duration, so maybe it's exaggerated, we don't know. But that is a staggering I thought before I started this, it'd be of the order of seconds. You know, people see a glimpse, and then because they see a glimpse of something, they take 4.5 minutes. There's another weird thing going on with it. If you fit a model to it, there's a decline in time. In the early days, it was of the order of 13, 14 minutes, and it's declined over time. And I don't quite know why. I've got to double check this because I just find conceptually it just seems bizarre that this is going on. I honestly, if anybody's got any suggestions to explain this, I don't know why, but it appears to be a real trend. Not really clear why. Not really clear why they're so long. I know there've been reports. I mean, you can see there are reports of literally people have said they've been seeing things for hours, but it's not even caused by these big kind of outliers. It's kind of the core of the data is this 4.5 minutes. So that one's a mystery. So there's some quantitative measures. Like I said, there's not going to be complicated statistics in this talk, but people do describe Loch Ness monsters like an elephant, lumpy, shiny, not glossy, smooth, not smooth, like a snail. Here's some more. Overall body shape can be like a barrage balloon, boats, duck or a swan. You see a duck or a swan on Loch Ness, I can't help but think, you know, it looks like a duck or swan.
Perhaps it is.
Why would you think it's a monster? But anyway, upturned boats, that's really common. That's a really common metaphor that's used in Loch Ness. They describe the Loch Ness Monster as a single upturned boat, single hump thing. And I think that is evidence. It's so specific. I think that is evidence that witnesses are kind of aware of what other witnesses are saying. Eel or a snake, whale, horse, periscope, tadpole.
So if you put all these descriptions into AI, what picture would it come up with?
Yeah, I've not done that. I've done, well, we'll see what I've done with it in a moment or two. Colour, black or blackish, that's probably the most common one. Grey, brownish, same colour as an elephant. I hate metaphor, because what does that mean? Elephants can be different colours. I'm guessing it means the light grey colour on top, but I don't like it when witnesses give metaphors because it's difficult to work out. Is it a metaphor or a simile? Whatever it is, but it's difficult to work out what's going on. Green and brown, pink. Implies to me perhaps we're not seeing the same animal. Anyway, you can put all these things together, and well, I put some of them together. I've got an MSc student who's working on. I've had two MSc students working on kind of alternative. I'm not really a multivariates person, so anyway. So what I've done is I've put in all the most common fields that occur in Loch Ness Monster sightings and put them together with the aim of doing k-means clustering, just to see what groups would come out in this analysis. So you could think of it as being particular types of report, whether they group together. So I've considered things like overall description, head reported, neck reported, was there a main or a dorsal fin or something like that? Bearing in mind that people, of course, may have misinterpreted what they've seen, they may have put a spin on it which wasn't actually there. The number of humps or coils, number of limb pairs, the number of tails. Was the object reported to surface? Was it reported to submerge? Was there a wake or a wash? Did the object reported move in the water as opposed to just remain still? Its reported colour, the texture of the skin, lots of different records. And then I put them together in a k-means analysis to see what dropped out. And then we got, well, 12 different types. There's a 13th class, which is basically reports with no information. So I won't talk about those because those are kind of boring. And you can see that what have we got? Well, if you look at the little icon on the top right, then this tells you, so the first one is like an object is seen moving with a wake. Report type 2 is a uncoloured single, well, it's a hump where colour is not mentioned, a single hump. Report type 3 is a black hump that's seen to move. Report type 4, multiple humps with a wake seen to move. Remember that, please. Moving hump with colour not mentioned. So notice many of these clusters are clusters due to the amount of information in the report, not necessarily kind of what was reported. Report type 6, multiple humps going up and down and seen to move. Report type 7, single hump going up and down. Port type 8, single hump moving up and down and moving with a wake. Head and neck, port type 9. Humps and the head and neck, port type 10, seem to move. Port type 11, a moving hump going down and a wake, just going down as opposed to going up again, and then a single hump where they just describe it as a single hump. So once I had those clusters, I did a multivariate vectorized GAM actually to see if there are any patterns in the proportion of groups reported through time. So what we're seeing on this graph is year on the x-axis, and then the probability of a report being of that type in each of those years. And the solid black line of what was actually reported are the actual frequencies, and then I fitted this vectorized GAM model to it, which is kind of a smooth, and then the dashed lines are 99% confidence intervals. And the point I want to make is, what you can readily see, is that the report types fluctuate in time. Now, you might argue that if there is one particular unknown species in Loch Ness, you wouldn't expect multiple report types. I suppose you could be that people see different aspects of it. I suppose that's a possibility. But you can see that they fluctuate, and they seem to fluctuate in quite a substantial way. I mean, when you fit the smooth, there's still a pattern there. But what's really interesting is that some of these fluctuations, they occur in particular periods, and I've kind of grayed out two regions. One is the initial period, 1933, 1934, and the other one is the period of the 1960s and into the early 70s, when that organisation I mentioned before, the Loch Ness Phenomena Investigation Bureau, was doing their activities. Now, what those guys did was that they got the witnesses to fill in these report cards. And that means that they collected information from those witnesses that perhaps wasn't collected by reporters interviewing people, or casual reports in letters and things like that. Specifically, they asked them whether they'd seen a wake, and they asked them whether they submerged and things like that. So what we're seeing in this pattern, again, is not necessarily about Loch Ness monsters, but it's telling us about the human activities in the lake and how the data is being collected. So the patterns we're seeing are literally reflecting the way in which human beings are collecting data. And we see that report type 12 is only recorded really in the period 1960 to 1970. It's not really recorded anywhere else. And in fact, more generally, you see report type 9 seems to go down during the 1960s, and so on and so on and so forth. So this points to me as if, again, there are human sociological, sociology is the right word, I'm not 100% sure, for what's being reported at Loch Ness. It's not just a biological phenomenon, it's not just a psychological phenomenon, it reflects a kind of cultural thing that's going on as well. So that's the way in which I think we can use anecdotes as data, and it can tell us some really interesting things about reported phenomena, and maybe it can tell us some interesting things about an actual thing called Loch Ness Monster. As you probably guessed by now, I'm a bit sceptical about that, but I still think it's kind of interesting to telling us about the activities of these different groups. I'm not sure this is the final results of the multivariate clustering. Like I said, I've got a master's student just working on kind of improving the techniques. And I think we probably can improve on that. But once we've got those report types, we can then look at the report types and compare them to other variables associated with the lake. And one of them is what the Beaufort sea state is. And you can see that there's quite a lot of fluctuation, but there are certain report types that are only associated with low Beaufort sea states. So we can see report type 1, report type 10, report type 8, report type 4, all associated with very, very low Beaufort sea states. Was it 1, 4, 8, and 10? Oh yeah, and 11 as well. Now, many of those classes are classes that are associated with wakes. And I work with a gentleman called Adrian Shine, who spent a lot of time at Loch Ness, also a lot more as well. And it's readily believed, it's actually been believed since really the 1960s, that at least some Loch Ness Monster reports were generated by people seeing wakes where they don't see the boat which is generating the wakes. And this seems to be borne out by the statistical data. So what we're seeing is, well, one, we see the classes of monster report associated with wakes only occur in very, very low Beaufort sea states. Also, it's thought, though, that the multiple humped Loch Ness Monster reports could be generated by people seeing a wake. Unfortunately, I haven't got the data to really allow me to confirm this, where they're low down relative to the loch. So they're looking at the loch, not from above, but looking at it really by the side of the loch. They're seeing a wake, the boat's disappeared around the headland, and all they can see is a sort of profile view of a wake. And it's giving the impression, and I've seen this definitely happens, of a kind of thing that's doing this. So they're interpreting that as a hump monster. And why shouldn't you? I mean, if you're a naive person who's come to a place where you think there's a monster and you see that phenomenon, why wouldn't you think it was? That's not kind of, I don't think that's irrational. It's just a reasonable interpretation of what's going on. And it appears that that's been borne out by the statistics. Other types of monster perhaps aren't being generated by that phenomena. So perhaps a head and a neck by itself, that isn't nothing to do perhaps with wakes, and so it's not associated. So then look at report type 9. Report 10 is that, because that is associated with low Beaufort sea states. So I still haven't quite figured out report type 10. But report type 9, you can see it's associated with a higher Beaufort sea state. And report type 9, well, the view among skeptics is that report type 9, well, report types that talk about heads and necks are probably people seeing birds, maybe otters, but something like that. We can also consider, well, I'm at St Andrews where we do a lot of distance sampling, so I did feel I had to look at reported distances and report type as well. And we can see again that they seem to fluctuate a bit. Report type 12, that's the one that stands out as being a long distance away. And that's one really with very little information, right? It's just a black hump. So, you know, maybe you can't make out, if it's a great distance away, you can't really make out what's going on. So these sorts of patterns in the data. And I think this is really interesting. For those of you who believe in the existence of Loch Ness Monster, maybe you're a bit disappointed, but I think this is kind of an interesting story to tell about human psychology and sociology and these sorts of issues. I've also looked at some marine data. It's a bit more difficult to do this because it's not located in one place and all this sort of thing. If you just look at first-hand ones, what you see, one interesting thing is that the patterns that you see are rather different to the patterns that you see in Loch Ness, in that we've got this massive peak in the 1800s associated with the period 1817 to 1821 in New England, where lots and lots of people reported seeing sea serpents. There was another little bump up here. This corresponds to the Loch Ness Monster stimulated people to start reporting monsters elsewhere, so that's what's going on here. But this was quite a phenomenon in New England in that period, 1815 to 1820. I can give you a separate lecture on that, but it's not very statistical, so I'll move on. How reliable are witnesses given the reporting process? Well, most of the time we don't know truth, so we can't say, but I have done some experiments actually looking at this and done some other bits and bobs. So the first thing I did look at was just looking at, I said before that you've got witnesses who have got the same witness can report an encounter multiple times. And you've also got different witnesses reporting the same encounter. So you can use those as a way of just seeing how consistent they are in their reporting, because that gives you a sort of upper bound on their consistency. So if you plot, for example, the reported distance by the same witness in the encounter reporting the encounter at different times, so they saw it and they reported it once immediately afterwards, and maybe a year later or something like that, and you can see that they're pretty consistent. That's the left-hand case. Same observer, same encounter. That's what SOSI stands for. You can see they're pretty consistent. If you take different observers of the same encounter, they're still actually quite consistent, but they may have talked to each other. That could be definitely a source of bias there. But it's less consistent than the same person talking about their experience. Which again, you kind of, this all agrees. There's nothing I said disagree with common sense really, but it's kind of nice to get a quantitative kind of view on this. And so you can look at those rows, those correlations for lots of different reported phenomena, and then see, just how consistent they are. So I've done this for the same people reporting the encounter, different people reporting the same encounter. So that's light greys, same people, dark greys, different people. For the initial reported distance, the nearest distance, which can be a lot shorter, the total length, the seen length, how far was the, what they estimated the Loch Ness Monster to look like, and what they actually saw, what length they actually saw of Loch Ness Monster. Sometimes it's kind of an unspecified length, so we don't quite know what length refers to, and then duration as well. And interestingly, duration of single witnesses reporting the same encounter is actually moderately low compared to other situations. Don't quite know why that is. So there's some mysteries there. And I guess really, this gives us an upper bound on how consistent witnesses are. That's sort of measure of witnesses. But it's not, but that's a very basic kind of investigation of that. I did do a formal experiment where I actually knew what was going on. So I placed a model monster on Windermere in the English Lake District, got people to look at it, and got people to say what they saw. Here's my monster. I was on a budget, right? So that was, but it's still quite a substantial thing. It was 2.6 meters tall, seen from a distance of 337 meters. And people, sorry, that's what they said they saw. What they actually saw was 2.22 meters, so pretty good height-wise, inverted J-shaped monster at a distance of 531 meters. Now, underestimation of distance across water is really common. It occurs in wildlife distance sampling. We'd expect that. And that, what I didn't do here was I just had a tall, pointy monster. I didn't have a wide monster. That might have implications for estimation of length. Because if you think the thing is closer to you, sorry, further away closer to you than it actually is. Hold on, have I got that right? It's closer to you than you think it is. Yeah, it might seem bigger. I've had that story clear in my mind. There's something, yeah. Anyway, there's going to be issues about your estimation of size if you misinterpret the distance. Yeah, children make very lousy witnesses of monsters. Females underestimate the height of a monster. Males overestimate the height of the vertical monster. Draw your own conclusions. Female drawings were more accurate than male drawings. There are other clues that can tell us, indirect clues that can tell us about eyewitness testimony. Truth seems quite a kind of interesting issue. Marine monsters are reported bigger than freshwater monsters, which makes sense on biological grounds, depending on what people are seeing. As you can see here, so we've got reported length, and you can see freshwater monsters are closer than marine monsters. Am I okay for time?
You're okay, we've got another 10 minutes.
Okay. So we can explore, using statistical means of a few assumptions, we can explore issues like, how accurate are reporters. And then I started thinking about cultural impacts. How could we look and see whether what's being reported reflects cultural influences on people? So I and my colleague Darren Naish were interested in exploring a hypothesis that was set up by the skeptical writer Leon Spruill de Camp, who was a writer of fantasy novels and a kind of writer on science, and he wrote things like The Goblin Tower, Conan. He wrote some of the late Conan barbarian stories after the originator of them, and various things for pulps and everything. And he said in an essay in 1968, after Mesozoic reptiles became well known, reports of sea serpents, which until then tended towards a serpentine, began to describe the monster as more and more resembling a Mesozoic marine reptile like a plesiosaur or a mosasaur. And he wrote this in an essay in 1968, but he didn't provide any evidence, which is a bit cheeky for somebody who's writing about skepticism and evidence-based and everything like this. And I thought, well, okay, well, I'm in a position to test that now. I can look at the trends in these reported monster accounts and see if he was right. And just give you a timeline then. So the ideas about Mesozoic marine reptiles started, the first kind of books about it occurred in the 1830s. And it was popular discussion, perhaps. Here's a cartoon from Punch magazine, 1848, where two drunk naturalists are discussing what the serpent and ichthyosaurus. Nonsense. Second naturalist. Who said ichthyosaurus? I said plesiosaurus. Plain enough. So you can see it was part of the cultural discourse of the mid-19th century. And so were marine reptiles moving from the snaky to the more plesiosauri? So the plesiosaurs are the ones with the long necks, like the one that's having its head bitten off, neck bitten off there, in the course of the 19th century. Yeah, well, they were actually. Generally speaking, if you look on the right-hand side, and my mind's just gone blank, I can't remember what the difference between the rows is. No, my mind's gone. But if you look at the black line, that's probably the most relevant one, that's the proportion of reports that report whether an animal is reported as being snake-like or serpentiform, right? And you can see that shows a decline over the 19th century. Well, actually, since 1800 to the present. Whereas the number of reports with necks are mentioned, generally is showing, that's on the right-hand column, generally showing an increase over the last 200 years. So there's something going on there. Is that because of wider knowledge about Mesozoic marine reptiles? Not entirely sure. We can also use cultural impacts to test accuracy. This is the final topic. This is quite fun. This is the first stuff that's been, this is unpublished. So sea serpents are often reported, and Nessie are often reported this sort of shape. And this is biologically impossible. It'd be a really stupid way for an animal to move because its movement isn't giving any kind of push against the medium it's moving in. And of course, if you go to Loch Ness, you see stuff like this. This is photographed 2.5 weeks ago at Drummond Rocket. And you can see this is a common cultural motif associated with the Loch Ness Monster. But I wanted to get a quantitative measure on this. So I thought, okay, well, I'll go on the internet and I'll count up the proportion of Nessie postcards. So I thought that was kind of a measure of a cultural thing, which have hoops or loops of this form, which is biologically impossible. And then I discovered there was actually a book called A Postcard from Nessie, which offered a different sample. So I did that as well. And if you look at that, you find that 25% of the 60 postcards I found, first 60 Nessie postcards I found online, had hoops or loops. 32% of the postcards mentioned in this book, Postcard from Nessie. If you're into postcards about Nessie, this is the book to buy. So a pretty small select audience. 32%. So you can see it's a big proportion of the reports from Loch Ness. What proportion of reports from Loch Ness do you think have hoops and loops?
3%.
3%?
1%.
1%. Well, yeah, you're pretty close to the truth, actually. 1.5%, 2.4% if you add coils and undulations as being descriptors as well. There's no trends in time. So I think that's really interesting because that's saying, despite this kind of this stuff, the witnesses aren't reporting this stuff. And that tells me that the witnesses, they're reporting the truth as they see it. Most of them are, not all of them obviously, but most of them are, because if they were just reporting what they expected to see, they'd be reporting this stuff a lot more frequently than they actually do. So we can use, and so that's sort of like a test of eyewitness testimony as well, right? Because we can sort of say, okay, well, we expect a high proportion of these reports to be these hoop things and not these hoop things. So that's sort of telling us something about the witnesses. So to conclude, then, I think you can do stats on strange things, like anecdotes about strange things, if you correctly identify the statistical population and what are the biases. And that's tricky to do, because there could be all sorts of biases sneaking in, which kind of altering things. The data reflect what is seen, but also biases in the transmission and the data collection processes, and you've got to kind of be aware of that. But there are still some strange features in the data, like duration of report thing, that's weird. Trend in duration of report, that's kind of weird. There are complex cultural influences. You can see that in my multivariate analysis, my chronological analysis of the multivariate data. But we can also see it's the non-effective cultural things in the last analysis I just talked to you about. So I think that witnesses are mostly telling the truth, but there is misperception going on, misinterpretation. There's lots of more quantifiable questions that can be asked. Can we classify reports and compare them to living animals? How precise are the reports? More on discovery curves. Zoom in on particular locations. I want to do a spatial analysis of the Loch Ness data to see where the reports, well, the reports are being made really about the centres of population, but how does that relate to what's being reported, these report types? Do they occur where ducks are, things like that? I've got a separate line of research about how big animals can grow. I should just mention some collaborators. There are people, believe it or not, who collaborate with me on some of this stuff. Reputational damage to them. So those are my thoughts on the Loch Ness Monster and others. And if you've got time for questions, I'm happy to take some questions.
We're come to 4:30, but I think somebody's desperately wanting the room for the next hour and a half, so I think we'll be fine.
Can I ask a question about the hoops and loops? Because where did that originate from, having loops? I think I missed that if you explained it.
No, I didn't. So I've looked into that, and the honest answer is I don't know. The earliest thing I found is a 3rd century BC pot from Greece that shows what would have been called by the Greeks Ketos, which is their generic term for a sea monster, and it shows a sort of hybrid animal that's got features of a shark and it's got a mammal-like head, but it's moving, it's like this. That doesn't mean, of course, they thought it moved on the surface like that, because the sea isn't shown. There are some Roman mosaics in the Vatican Museum which clearly show an animal at the surface with hoops. And then, what's the next one after that? Next one after that occurs, it's a complicated story, but there's a giant worm that's reported in a map of 1522, which then becomes a sea serpent in a later zoological text, which definitely has got that characteristic. And there's a quote in the separate text by Conrad Gesner, his historian Anomalia, where he talks about the what he calls spirals being so high that a boat can move underneath them. So it's an old established idea of this kind of thing. I suspect it was originally done for stylistic reasons and then became part of the associated system.
It's also because having visited Loch Ness in the 1870s, I think it's probably too missing. But you weren't born, but
No, well.
During the 1960s and 70s, a great deal of the shops in Scotland would sell the kind of the stuff that got smashed by Godfrey Jones in his visit to one of the gift shop, which actually did have Nessie involved in it. China, little pieces of china, and these ornaments. So I mean, I don't think they're readily available anymore. But this was a kind of classic thing to sell in these shops. Would be two or three hoops, a tail and a head, but you could sit in your mantelpiece. So this was your souvenir of Loch Ness, and so it may be that it makes a better image for selling to tourists, which doesn't diminish your explanation at all. But it may be a better image, because if you try and sell it, the image of the lump.
Yeah, a lump is, yeah.
Who's going to put that in the mantelpiece? But having this little thing that kind of is.
Yeah, it's aesthetic. Yeah, you're right. It is aesthetically pleasing. So I think that could be the
I also think because it's a sea serpent, if you look at land snakes, when they move like a sidewinder on a desert, it moves like that, which is why I would explain that. But then also with regards to like a loch, and if the water is very disturbed, it's going to look like waves. So if you see a head, you would assume that's the head, and then the waves are just the body. But then the fact that majority of them were in the Bedford Sea stage or something, when it was flat, that just wouldn't make sense.
Oh, I haven't really looked at hoops and loops in relation to both the sea state, actually.
Because if it's flat, you would expect it to just be a head, rather than you would, like if they saw it when it was flat, you would
you're saying that the action of the waves would give an impression of hoops and loops, where you wouldn't. I'll have to check that actually.
I think that it's sort of provides more evidence that people are telling the truth based on what they say, because they don't see the coils when it's not a rough lock.
Yeah, I'll have to check that. But yeah, I don't see the reason why.
So I have a second-hand experience. My brother-in-law, on a bus going from school out to the west coast, from Dingwall, the whole bus stopped because there was this phenomena, whatever it was. Now, okay, they were schoolboys, they could have all egged each other on, but my brother-in-law was quite serious. He says he just saw, he didn't see any hoops and loops, it was just a blob.
When was this?
Well, he would have been, I suppose it would have been in the 60s.
Okay, I mean, that side may well give us on, because there
So
are
it's a lot older than you then.
Oh, yes.
there are certainly from the 60s there are reports. There's one in particular actually, it's quite an interesting one, where it was a whole gang of schoolboys did see it, and we've got about 15 different drawings.
It might be his class actually, because I think they were all
Are the drawings all the same?
Yeah.
No, they are slightly different, but some of them have the same features. But it's an interesting test of kind of eyewitness testimony.
Yeah.
I suppose my question would be: have you looked at the origin of the people who cited it? Because often people who are familiar with a particular environment will recognise some phenomena in that environment and not respond to it, whereas people unfamiliar may think, gosh, that's...
Yeah. But I mean, this was a trip that this coach load of lads would have made every week. It would have been a very familiar landscape.
Sure. I mean,
so,
I'm not saying this,
that's always going to be the case.
but in a more...
And they would have seen it in all sorts of different weathers. But the other interesting thing, I was quite interested in you saying that if they were down at loch level, they wouldn't have been. They would have been at that road level, which is actually quite high up, isn't it? So that
would probably preclude it being a wake effect.
Yes.
But then that would make sense because we don't associate the wake effects with single humps. That's a kettle of fish.
Yeah.
There's lower road in sense.
Yes.
But it's
very, very rarely used, isn't it? I don't think it would have been used in that time.
No,
not for the.
I mean, you drive at 20 miles an hour.
Yeah, I mean, it's
and try not to crush any squirrels. It's that kind of.
Sorry, just repeat. You made a point before, and I forgot what it was.
Okay, my point was that people that when you don't know an environment, you may.
Oh yeah, about that professional occupation stuff.
Yeah, well, either occupational or just familiarity. So one of the things about Loch Ness is from the perspective of most tourists is it's a remarkably different environment from where most people live. But most people simply it's not a practical place for large populations to go, and so they're not used to water like this, and not used to reflections, or not used to what might be on the water and so on. So what to somebody else might be, oh yeah, that's such and such, to them might be really quite mysterious, and it's subtle. I mean, I've been out walking with some, and their shoes were soaked, and mine were completely dry, and it just occurred to me afterwards why that was so, which is I was familiar with typical Scottish flora and was pretty well aware that if you're trampling, if you see bog cotton or moss, it's not a good place to step. If you see thyme, that is a good place to step. So and driving, so my feet just followed the pattern. Walking with somebody who had no idea. They didn't see what was right in front of them, and similar to that, London people, that is something to look at. We have people who are not familiar with the environment. I know your example is a reasonable counter example to that.
But I just wonder how many then, who are local, if you like, is there, and actually, I mean, there could be more bias because obviously.
Well, yeah, people often say, all the witnesses owners of hotels. I do have, for some reports, I do have who they are, especially if they're like police officers, things like that, because they're very keen on doing that. I don't think the data is sufficient quality for me really to do anything quantitative with it. I'd like to, but I can give you an anecdote. There's a gentleman called Steve Feltham who's lived for the last 20 years on the eastern side of the loch.
Oh yeah, he's in the caravan.
He lives in the caravan, right? And he's only seen the Loch Ness Monster once. And he spends several hours a day scanning the loch.
Is there not still a boat that goes out? Is that stopped now? There was for years there was a
there's several boats go out. Some of them with sonar, some of them
that's right.
So that's still a thing. You can hire a boat.
But there was a research team out.
Yeah, so Adrian Shine was the person that I work with. He's done a lot. He was kind of involved with the Loch Ness Phenomena Investigation Bureau and then worked a lot more. And then he sort of brought together, lots of the kit that they use, and that formed the basis of the Drum and the Rocket exhibition. But he's my kind of Loch Ness based collaborator on this because he was the person who kept all the cards of the NIV, which allowed him to do the analysis. So there's some nice, getting back to your question, I suspect the more familiar you are, cannot prove, more familiar you are with the lake, the less chance you've got to see the Loch Ness Monster. That's my gut feeling.
Yeah, and it is also a kind of expectation. I mean, we already know people sometimes will see what they expect to see. So there is maybe this kind of, people describe things, for instance, UFOs. UFOs didn't really start to become a phenomenon until the mid-20th century, because before that, the idea of a flying object, there's almost no record of it.
Well, there are weird. Sorry, I should interject at this point. I have taken a little interest in trying to do the same thing with UFOs. But there were strange airships in the late 19th century. But one interesting, I briefly looked at the UK, used to have a UFO desk at the MOD, and there's a guy, David Clark at the University of Sheffield, who's collected most of the information they got from there. And I wanted to do a similar analysis. I looked at it briefly. One thing I did notice with that data is that in the late 1990s, you see a new class of UFO appears. That's black triangles. That wasn't a thing before the 1990s. There's an obvious explanation. That's stealth aircraft. So again, we see a phenomenon that's being reported, and there's an underlying reality to what's being reported. Now, I don't think we're being visited by extraterrestrials.
Yeah.
But I do think there's an element of there's reality there. And I actually suspect, this is sort of heretical belief actually, but I do think actually the tragedy of the ufology thing is that there's two kind of extreme points in there. One is would be visited by extraterrestrials, and the other one is it's all a load of rubbish. And actually, in between, there are all sorts of, there could be strange atmospheric phenomena being reported. Yeah. That happened in World War II. There were these things called food fighters and stuff. So I think there's some really interesting stats that can be done on that sort of stuff. But I'm going to stick with sea monsters, really, because that's stuff I know better.
That's because you know sea monsters.
But yeah, so I think there's really kind of interesting questions you can ask. And it's the tragedy of it is, and it does, is that, I know this, the response to my papers is sometimes people go, it's not response, it must be rubbish. But I hope I convince you that actually this is kind of reasonably good quality science. It brings in questions about what is the nature of data and all that sort of stuff. But I have found problems publishing some of my work, actually. Two reasons. One, I think sometimes a knee-jerk response, and also interdisciplinarity. It's quite interdisciplinary in some journals. They just couldn't cope with that. And I should also say that some stats journals, which claim to be applied journals, are like interesting applications. And I said, well, here's an interesting application. There's no theoretical development, and they go, no. Well, I say, well, look, you say interesting applications, and they still say no. That's kind of frustrating.
But actually, you're right, because we pride ourselves on collecting data and blah blah blah. But actually, when you think about it, the English department have quite a wealth of information from the Doomsday Book and all sorts of different social concepts. And stuff. Yes. This is probably more anecdotal, as well. So actually, we shouldn't be as snobby about it in that sense. We have an obligation to learn how to deal with it.
The old statistical count is not really adequate to a statistical analysis. partly because it wasn't systematically collected, and yet sometimes the detail is
phenomenal.
It's phenomenal.
Yeah,
It just tells you how many widows and orphans there were in a parish, and you then and that was one of the more specific questions we started doing, because they wanted to know if we set up pension schemes and insurance funds, how much would we be paying out? It was a big question. Very interesting.
So I think that's quite important in that reference, to the behavioral and cultural and social at the individual level, society level, or for community level, how it is changing. Whatever the truth is, that's another matter. But how we are behaving similarly or differently, so that could be still crucial.
Very interesting.
And many of the marketing things in your business possibly work on those kind of things.
Absolutely. Yes, absolutely. Yes, what
How people behave.
how you're being led up the path.
Be attracted to a particular product. And that's possibly Loch Ness could be a really nice experiment.
Once I've got, I'm sure other people could. Ultimately, I want to. There's a lot more I want to do with the Loch Ness data, but ultimately, I want to make it publicly available so other people can go and play with it and stuff. Because I think I'm sure there's other people who have new ideas about it and all that sort of stuff. It took me ages to compile it. I had to sit there and go through it. I think it tells us some interesting things. Probably not about Loch Ness monsters, but about humans.
Yeah.
Thank you, Charles. Thank you very much. I think it's been brilliant to hear, as well as just as we're talking about there at the end about the perceptions and how that influences how the data's collected and what the data actually record as well, which affects me in manufacturing, and I'm sure it affects people in the clinical trials environment as well, in so many areas of application, that sometimes we really need to kind of make sure we remain aware of what it is we're collecting. So thank you, good food for thought as well. So thank you very much. Thank you, Charles.